I'm going to go through these slides and I will show you basically, yeah, this is what we're gonna do these 2 days. And yeah, this is the outline. So I will very quickly tell again, probably something that you already had the chance to read around, what is FAIRmat. And also we are doing mainly research data management. And so I will just point which are the roles in research data management, and then the main activity that we do, structuring data. And then I will go a little bit into the software. So what is this meta info that you might see all around when dealing with Nomad? And what is an archive? That is the basic file, the basic document of our document-based database. And then these levels of schema, because every archive is usually it has a structure, and this structure is a schema. So there are several levels of schema that I'm going to explain you. And then this is the main activity that you want to learn in these 2 days. So how to parse some of your files and how to normalize some of this information. So how to apply some further processing to this data that you are uploading. And then we will get started with this dev distro. So I know that where is, I don't see. Oh, wait. Yeah, I know that Tommaso, yeah, if you're here, I know that Tommaso last days was driving you through this installation, or at least showing a bit. So we will start from there again. So you will fork this repo that Ahmed produced, and Ahmed is also here in this Zoom call. So he is another member of FAIRmat, and he's in another team. It's not my same team, because I am mainly dealing with synthesis data, while Ahmed is in the team that is of the core developers of the infrastructure. So yeah, and yeah. So as I said, I will repeat Sartak, that is also here, is a member of my team, and maybe if we have time tomorrow, he will show you something about Jupyter notebooks and how to access the data that you loaded in your database through the Jupyter notebook and the Jupyter lab suite that we have integrated in Nomad. So let's see if we arrive there. If we don't arrive, there is no problem. Still, you will find all the information, and then you are super welcome to text on Discord for whatever doubt you might have in the next days. Okay, great. So what is FAIRmat? Is this project on the left that is now at its 3rd year and is lasting 5 years, and is funded by some German German research data infrastructure, and we develop a software that is called Nomad. So Nomad was existing since before FAIRmat, because it's going through several projects, and so during this project it was open also to experimental data, not only computational. It used to be only focused on computational data. Now it's also, as you see, in synthesis and experiments. And yeah, we are divided in 7 teams. So I am from the synthesis one. Then there is the experiment, computation, and then the infrastructure, that is the core development team, and then use cases, because we want to slice all this information also not only in synthesis, characterization, and computation, but also transversally into several use cases, for example, batteries or catalysts or things like that. And then there is some training and coordination that are also in charge of either doing some outreach or just coordinating the very important administration part of this. Okay, we are a bunch of people, so 30 of us are the internal ones. We are postdocs, and we are employed by the Humboldt University, and then there are around 60 PIs that decided to collaborate to the project, and so they are delivering some data and also giving us feedback. Because this is how we develop the database, so having feedbacks. So that's why it's also important that when you try to use it, you give us feedback if something is not working for you, or it's not clear, or stuff like that. Yeah, so these are the areas that I already mentioned. And what do we do during the day? We deal with users, and so this is just a funny collection of memes, typing research data management memes in the web. And yeah, so we want mainly to structure the data. Okay. So the next thing that I want to highlight is the roles in this kind of activity. So there are mainly three roles. So the first one clearly is the user. So the user is exactly the scientist that wants to organize in a way some research data management platform or workflow, and yeah, so they have to use some kind of application. Then if you go to the next level, there is the application administrator. So this is something very similar to what is my position in this job. And I am a scientist, I'm a chemist, but I am actually dealing the whole time with the research data management. So I'm going through some more programming tasks and stuff like that. And so I have to prepare the application that will be needed for a specific user. The deeper level is the system administrator. So the system administrator is usually providing a server, is providing maybe a virtual machine, or also dealing with all the technicalities that are allowing you to use Nomad into a larger facility. For example, they have to deal with this Docker that is a container service that is allowing to run specific containerized application like Nomad is. Or for example, they have to deal with the key clock that is the authentication database, or other, let's say, IT-based details that we might not know. So which is your role in here? I think you are in between user and application administrator, because you want to use it, but you also want to develop your own plugin, or let's say a Twitch extent, but you want to, yeah. So you are in between these two. Okay. So now we go a little bit into what structuring data means. So these are the main sources, and you might, I don't know if you already saw some video on YouTube in our channel, you might have seen this slide. So these are things that are repeated in our YouTube channel in other tutorials, because it's a typical introductory kind of information. Okay, so Elena can hear us. Okay, fine. Yes, so these are the main sources of data. You can have raw data from instruments. You can have this metadata that you might write on the paper, or better on an electronic lab notebook. And then there are all the data from the data analysis, that is the post-processing of your data that wouldn't make sense without some further analysis. So the thing that you want to put in practice, starting from these 2 days and maybe in the next weeks, is to go from the left side, where you have some paper metadata, some random measurement lying in your folder in your computer, some Excel sheet and stuff like that, to the right side, where all these things are uploaded in Nomad in several ways. We will see how. And then all the data is collected in one single place, and then you can have this unit of information that are lying in a single database, and then you can search for that and even expand the kind of wishes you might have on what you want to do on your data. So let's see where we arrive. But yeah, as I said, it's very relaxing, so you can just listen to me and see what you can do in these 2 days, and in the next days you can put the hands on again on the material I prepared for you, and you can start having some questions. Okay, so structuring the data is important. Also structuring the metadata, that is what is around the data. So let's check which is the difference between these two concepts. So the data are what we might easily imagine. So arrays, numbers, stuff that we measure, or the actual plots that we put in our papers. Metadata are data that provide information about other data. So it's other numbers, but they are not usually intended as the core thing of the measurement or stuff. There can be several kind of metadata actually, and I just reported 2 of them that are important for us. So the structural metadata is something very technical that is only describing the shape of the containers of data. So in this case, you see I defined some XRD measurement with two magnitudes, 2 theta and intensity. And then a structural metadata is, for example, that the unit of 2 theta is in degree and the type is a float, or the type, or the unit is dimensionless. So this is a kind of structural metadata. Another kind of structural metadata is what you will find when you upload something in NOMAD. You will find a dedicated section to this. And as you see, there can be an upload ID or entry ID or other things like that. So these are just metadata without any scientific content. It's just about, let's say, organizational or technical, data stick to the actual numbers. Then we have the descriptive metadata, and this might regard all the information that are around the experiment that you might write on the paper, or even not write and just write in the file name of your raw file or stuff like that. So usually this descriptive metadata has got a scientific meaning, and what we are usually saying within our project is that we want to extend the set of metadata that we record and put in a machine readable way, so that we can then run some AI-based algorithm on this data, and we can even sketch some new correlations between this metadata that we are not aware of, just looking at the data with our eyes. So it's very important to write down as many stuff as you can, because you might find some correlations into this data set afterwards when analyzing the data. For example, you are seeing some difference in your spectra from one day to the other, and you are like, what's happening? And then you realize that it's the humidity in your glove box or in your room or stuff. And so if you write down this parameter, then you will be capable of understanding this through a programmatic analysis of the data, not usually just with our eyes. Okay, so how do we structure data? Creating a data model. So this is the main word you will hear from here on when dealing with these things, and is the schema. So the schema is exactly with this metaphor. The schema is just the blueprint of, in this case, of a toolbox. So we are just sketching which are the dimensions of our toolbox and giving all the technical details and the theoretical details of this. And we can usually write a schema in our database as a markup language file. So for example, XML, JSON, Markdown, whatever. So from the schema, we are ready to create a template. So a template is a physical object, so a file in this case, and is an instance of the schema. And this template will have the structure that was taken from the schema. And then this template can be filled. So so the template concept is also important. The template is an instance. So I can do a lot of templates from the same schema, and then I can fill them with different data sets. And indeed, what we end up with is this. So from the schema, we create a template, and remaining in this metaphor, we can fill the toolbox with some instruments, and then we will have a structured archive file. So these archive files are the things that will be created in Nomad, and they will be there. They can be even downloaded. They appear like JSON or YAML files, and and they are let's say at the basis of our document-based database. Okay. So what do we need to write a schema? We need usually to write some Python code. And as you see here, there is one example file that is physical vapor deposition.py. This is somewhere in some repo that I will show you later. And so we just have to write classes. So these classes, if you are more or less familiar with Python is an object-oriented kind of programming. So we create objects. So this class will be the class from which we can create objects or templates. And I will show you just in the next slides that is very important that when we create a class, we can inherit properties from some other class. So in this case, physical vapor deposition is inheriting from vapor deposition that is meant to be a more general class. So we will create a tree of inheritance in which we specify more and more. And then, we have these kind of things. So there will be properties in this class. So these things that are written here before the equal are called properties. This can be, as you see, different elements. So we will go through each of them very slowly later. So which are the main tools in object-oriented programming we are going to use? As I said, the inheritance is one of them. So this is based on writing some class, defining a very general part of information, and then specifying that class depending on either different branches of the knowledge we want to describe, or depending on specific needs we might have. This is an example. I have an instrument, so my instrument will have some properties, but these are very general. And then I want to write my own instrument, the one that I'm really running into my lab. And so I will need to specify the instrument class. The advantage of the inheritance is that, as I said, that you can inherit all the properties that are found in the more general class, automatically inherit. And so this will make all the instruments, even if very different, sharing some properties together. So these properties then will be searchable all over the database, and so it might be very useful. The other let's say tool is the composition. So instead of creating just a new class with inheritance, we are actually taking some class, in this case experiment, and then we are inserting into this class another one as a subsection, let's say, we are nesting it inside. So in this case, we know that one experiment will always contain an instrument, and it will also contain another bunch of stuff, usually sample, then the activity steps that you perform during the experiment, and these kind of things. So the composition is the other important object-oriented concept that is going to be used later on. I will show you an example also of this, and you will see that it's all about that when writing schemas. Okay, the next step is trying to show you some terminology that we use in NOMAD. So what is meta info? We already found metadata, now there is meta info. So yeah, this is what is found in our documentation. So meta info refers to the sum of all the schemas. And in particular, it is associated with all the predefined schemas that are used to represent all the process data in a standardized way. So the meta info is the information about the information containers that we have. And indeed, I placed here I Googled some meaning of meta. And as you know, meta is, as you might imagine, meta implies a level beyond, and it means that we can, it concerns, let's say, providing information about member of its own category. So there are these other examples that can clarify you which is the term, which is the meaning of this. So a meta theory is a theory about the theory, or the meta theater is something where the let's say the characters are really talking about themselves on the stage. Okay, so why is this important? Because you will find a lot of M underscore stuff into the code. And so this is always usually referred to meta info underscore something. So this can be properties of classes, as I mentioned before. For example, mdef is something we will look at later. And then there can be also some methods, so some basic functionalities that might be used, like mcopy. Yeah, this is just meta info copy, and it's just the copy of one element implemented in our database. Why we need to do that? Because we need to take care of a lot of details under the hood. So it's important not just to use some simple Python package to copy stuff, but really we need our own methods to do also the simplest kind of file management inside database. Okay, so this was just to explain why you will find this m underscore around. Fine, we can go also to the archive, and as I mentioned before, the archive is this field toolbox, and it's the basic kind of information element you will find around. And so what is an archive? If you opened already, sometimes Nomad, and then maybe you tried to create a new upload or even to surf the global Nomad, you have seen stuff like that. So on the left, for example, we have one upload, and as you see, there are like many lines in this upload, and as you see, each of these line is an archive. So it refers to a file actually. You can see the first line here, there is .json, and yeah, so it really means that one archive is one file, and then we can decide how big will be our archive or what our archive will contain, and also how different archives connect to each other. So it's all about creating these JSON files. On the right side, you find this view that you can get from the Explore button. So if you click the Explore button when you enter Nomad, you can look and you can see that there are millions of entries. Each of these is one file, one archive. And so, yeah, these are also archives. We will see that we can surf these millions of entries, selecting the filters here on the left. So there are several filters that you can go through, and we will also try to I will also try to show you how to customize these filters in case that you need some specific filtering for your data. I don't know, maybe you want to look for a specific temperature that is always present in your data sets, and so you might add this custom filter here. Okay, this is another archive, as I showed before. So from within the upload, I just opened one of those lines that was inside, and this is also put here to show you how Nomad appears. So each archive is showed in the GUI, and so the GUI will have these 4 lanes here, and now we are in the overview one. So in the overview one, you can have already a look at some structural metadata, as I showed you before, and then you can put in the overview some main information that you want to highlight. Then if we go from the overview to the data lane, this is the overview, as I said, and these are the metadata. If we go to the data lane, we will see the actual structure of our archive. Okay, so in the data here, we have like a nested structure. So we go into our JSON file, and we can see different levels of nesting. For example, the experiment will be my root of my archive, and inside it I will have several other quantities or several other subsections. And then while opening them, you will see that you will open the right lane, and you will go right and right until you will reach the very the nested most level of your archive. Yes. So this is, as I said, you can also get, you can also understand that this is an archive from the class that it's being used. We will go in the very detail of how to create these things later, but you can already have, you can already see it from the GUI. So you see that this entry belongs to the class entry archive. So this is the root class of our archive, is usually that. And then there are several important subsections here, and we will usually need to define then the class that will live into data. These other sections here are stuff that are filled from some database automatic processing, so stuff that we are taking care of. So you have only to take care of the data section. That is exactly where you want to write your own structure. In this case, indeed, there is an experiment that is a very generic one, but yeah, you can specify your own and go on. Yeah. So after, okay, this is exactly what I was saying. I placed here, so at page 35, this link to the docs that is leading you to where this image is placed into the docs. So you can read this with calm later on or whenever you want, but basically it's just explaining you what is an entry archive. That is what I just showed you in the GUI. So the root is this class here, and then it will have several things composed inside that are results that we will talk about later, metadata or data. That is what we are usually interested in. So this entry data class will be very important, and we will see some examples. For example, when we will write our experiment, this will inherit also from entry data. Why? Because it must be placed exactly in that place of the archive. So this is the general idea. Yeah, here there are some explanation that you are welcome to read, but now we can go on. Okay, good. So we learned that there is this data section of the archive that we have to fill with some classes, so with some schema. There are several levels of schema that we started dividing and that we can place in that data section of the archive. Which are they? So they go from very general one and in a way useless because they are so general that they are not useful for anyone. So these are called base sections. They are very general, not specific, and they are maintained by us internally. And there are no entry data. Yeah, this is because they are just meant to describe a part of the thing, but there is not the inheritance from entry data that can be placed when specifying them. So some examples are activity and process. So very general things that contain really only date, time, or name, or stuff like that. The second level are these standard plugins that are not laboratory specific, but at least they start to be technique specific. So we have this measurement, material processing, and I will put the link in the next slides, so you don't have to look for them now. And so as you see here, there is one example, physical vapor deposition, and that is collecting all the general stuff needed in these PVD things. And then PLD is pulsed laser deposition. That is one specification of PVD. So you already see that in this case, there are already two levels of inheritance. Yes, the third level are the user schemas. So maybe you look at this PLD available and you find that you are organizing your data in a slightly different way and you don't like that stuff. So you are calling your own lab underscore PLD and you are making that class specialized and say, let's say grafted, grafted on the needs of your lab. Why you need to inherit? Because you will inherit also the properties and also the maybe automatic processing that can be placed in these upper levels. So it's important as much as you can to inherit the existing stuff and not starting from the creation of the wheel again. Yes, so these are all the links. The base sections are into the main repository, and we will see the main repository because we will install it in our own environment to develop it, but you can also access it from the web. So it's hosted in the MPCDF, that is the Max Planck Computational Data Framework, so where our server is living, and then there is a GitLab deployed there, and so this main repo is there in GitLab. You can access it, only read. You don't have an account there, so you cannot open issues and stuff. But there is a GitHub version where you can open issues. The standard plugins are these ones, and we are going to load them in our development environment later on. So the main ones are NOMAD Material Processing, talking about synthesis techniques, NOMAD Measurements, talking about some measurement technique. There is not much, but maybe something can be taken from all of these things because we are constantly extending these plugins. Then Nomad Analysis is what is leading you to install something to use Jupyter notebooks around. And Nomad Simulations is describing the structure of some computational or theoretical use case. Yes, I'm not sure of all the classes that are into this one because I'm not looking at it personally, but yeah, it's also available here. And so in all of these, you are very welcome to go and take a look and to open issues and also ask questions or stuff like that. And then there is your plugin. That is what you're gonna deploy, develop, maybe start developing in these 2 days. And I placed here some, I think, important links because these are the plugins already in place. So from the IKZ, that is the Institute of Crystal Growth, that is behind my building here. Then the PDI is the Paul Drude Institute here in Berlin. Then the CNR, IMEM in Parma. I developed a small plugin for them as well for the MOFPE technique. And then the DTU is the Denmark Technical University. So we are developing, me and my colleagues developing these plugins, so you can probably find whatever you need in that code. So what I'm going to do in these 2 days is to explain you something and maybe hear your questions. But yeah, all the things we needed in the last 2 years are coded into these 4 things. So you might take that and even install that in your test development environment and take a look at that and make questions if something is not clear. Okay. So let's see which are these concepts here. Parse and normalize. This is a small image I took from the documentation, so I put the link here where you can find it. So which is the pipeline when uploading data in the database? We have a main file that is, let's say, a raw file that comes from our instrument or our CSV file or whatever that we want to load in NOMAD. So this is called main file. Then there is a procedure in the database that is inspecting this main file, understanding it, so matching this main file to a specific parser. And the parser is basically a reader of this file. So it's reading and understanding the file, okay? So if there are several, especially from computational packages already available. From experiments, not many. There is only, I think, functional is only the XRD one, but you are free and it's kinda not super long to develop your own parser. This is what we are going to look at later on. Okay, so after that you drag and drop this file into the database, into your dashboard of an upload, then this file is being matched and associated to a parser, and the parser is creating an entry, so this archive file. And then yeah, it's running some automated code that was coded inside this parser. It's creating the entry, filling the entry with the data from the main file, and then there is some normalization happening. What is the normalization? After that you parse this data into your archive, you might want to do some post processing or further processing of this data. So maybe some normalization will check if some quantity is filled in your archive, and if it is, something else will be performed. I don't know, maybe some normalization of some spectrum, or even simpler, just filling some concentration in different units or whatever simple processing that you want to stick there. So the important thing is that these parse and normalize are two separate kind of processing. One is happening only once, only when you upload the file. So you have to keep in mind that the parser only acts once, while the normalizer will act every time that you save again. You will trigger again the normalization. So the normalization will act many times, and so you have to be aware of this. Clearly, with the if statements, you can check if something is already being filled, and then you skip this step or things like that. But you must be aware that the normalization will act many times afterwards. Yes. So what you see here are, I think, this black small ball here are the raw data starting, and then you will end up with the same raw data, but somehow coated with the new layer of metadata or other data that are being calculated by this process. So you will have the same data, but with some additional information. Okay, nice. These links here are pointing to the snippets of code that I prepared and that I will show you today and tomorrow. So this is this Area A examples. In this repo, you will find a folder for the workshop of these days, and you will also find other folders. So you can look at that around, but all the stuff that we will do these days is in this workshop, January 25 thing. So we will have some info or some, let's say, yeah, we show you some snippets, some code snippets from the schemas, from the parsers, And then for this app, so the app is exactly what I mentioned before, that is the filtering possibility of your data. I didn't place anything specific in these area A examples, but I just pointed to the official documentation that is very, very nicely written. And one of our colleagues just implemented some new features 2-3 months ago. So this part is pretty new and is very nice, I think, to read. It's I would say self-explained. Okay, so we can go through that together, and yeah, and we can see what happens. And then there are these Jupyter notebooks, and I don't know how many of you are familiar with those. So Jupyter notebook is, imagine like a file in which we can have a file divided in cells. So these cells can host some Python code, and then the Jupyter lab, that is the whole machinery that is running these files, will be able to run that Python code and show you the output into the same file, and even save the output into the same file. So it's just an interactive way of running Python code. And together to these, you also get the nice feature of having the output saved into the file. So you can run this code once and then have a complete file that you can, for example, associate to a DOI and publish in your paper, showing that this was your AI analysis or any other feature, or even share with your colleagues, and you will have also the output of this code. So this is the place where we usually implement some further processing. So it's very clear what happened and which is the output and things like that. And indeed, we deployed inside our NOMAD software the Jupyter Lab suite. So it's just about installing it or yeah, let's say loading it into a container inside NOMAD. Yeah, okay. So after this, I started collecting here a couple of tips and tricks. Probably in these 2 days, I will write more here if I sketch something while telling it to you. But the main thing, okay, I hope that you have VS Code as this integrated development environment. I don't know if all of you already have VS Code, but this is what we are usually using. So VS Code is, so to say, this thing here. And this is very useful to code because it provides a lot of features to navigate your code and to go through it and stuff like that. For example, as I indicated here, whenever you find a keyword and you don't know how to use it, then it's just enough to go in your VS Code and write it here, and then you will see all the occurrences of this keyword that might be unknown to you, but you will find all the occurrences in the code, and you will be able to see where it is defined and also all the uses. So it's a tool that is very, very useful, at least for me when developing. So make use of this, and also, yeah, here we have as an example this madd subsection that is a method existing in Nomad. So I wrote this method in one of the code snippets that I will show you later on. And yeah, so I just found some of the examples on in our existing base code through our IDE, and that's why I wrote it here. So because it was the easiest way to find where these things are used. Okay. Then while writing something for you yesterday, I went through this common problem that is also pretty funny, because if you use as a unit min intending minutes, then the pint, that is a Python package, will misunderstand this min and will take it as milli inches instead of minute. So you have to write usually minute as an extended word. So this is something that everyone finds at some point while dealing with our platform. So I just wrote it here, so you will maybe remember. Okay, now I am almost at the end, and I just want to show the slides that Ahmed prepared about the Nomad distro dev. Yeah, So I will just keep talking, and yeah, if Ahmed has got something to add, you can just open the mic and speak up. And these things are being shown also to tomorrow to other people in the internal team. So this is also something that is being set during these weeks or months. Okay, so why this NOMAD distro dev? What's the difference between all of these things that you find? So yeah, so we need to basically load all the packages in a little bit a different way to be able to develop them. Indeed, all our application is based on Docker, that is basically containerizing or closing up in some executable, let's say, application, all the part of the software. And yeah, so we need to organize them in a slightly different way if we want only to use it or also to develop them. So we must somehow to have an interactive part of the code. So the Nomad distro dev is just a distro, so a distribution that is made on purpose to be able to develop the stuff. And the Nomad platform that you find in the web is also a distribution, because distribution is nothing more than an installation with specific package versions. So we can have as many distro as you want. For example, you in Trieste will also have your own distro. It will be your own Oasis, and this will mean that you will create your own image, your own Docker image with your plugins loaded in, and this is yet another distro. Okay, so let's see. As I said, some of the plugins that you need to develop will be installed in an editable mode. This means that when you change them, you can just restart your application and you will already see the changes into the code. And yeah, for example, these are the green boxes that are indicated here. And then you can also load some more plugins in a non-editable way. And these are indicated like the red ones. Clearly, everyone will have different plugins loaded and different plugins editable, depending on which one they want to develop. So to get started, as I think all of you have, you need to install UV, Docker, Yarn, and Node. So these are all the tools needed for that. UV is a package manager, Docker is a container manager, and Yarn and Node are taking care of the JavaScript part of the software, so the user interface part. I clicked this by mistake. Okay, now we were here. Yes. So yeah, after this, you need to fork this Nomad distro dev. So what does fork mean? Basically, if we are here in GitHub, then we see that we can do several actions. We can copy or download just what is contained in this repository. And this will just give us the files in our local. But we don't want to do that. We want to fork the repo. And forking means copy this repository in our GitHub account. So in this way, it will still be a GitHub a Git repository. So you will still be able to have this versioning service of Git. So you can already start doing that if you didn't do it yet. So it's about like clicking fork, and then as you see, you will be directed to this page, and you can choose your owner, as owner yourself, and then you can give your own name to this repository. For example, Nomad distro dev AA, in my case, just my initials, and then you can create a fork. Yeah, I have to select my own. I already have a fork, so I cannot do it again in front of you, but you can do it. And so we will start then from this repo that you create. Yes. So yes, indeed. After doing this, you can. Yeah. Let me do the steps. So I will go to my repositories because I already forked it, and as you see, is Nomad distro dev AA. After that you create it, then you can actually now clone it into your local. So I don't know if all of you did that, but we can check after the end of the slides. So basically, you copy the file here, you copy the link here, and then you just type in your terminal git clone, and then you paste that link. And this will lead you to have your this repository in local. So from there on, we can start the hands-on session and check what's happening. Okay. So before, okay, here is just Ahmed is just keeping explaining all the actions that must be performed. Oh, now it went again here. And yeah. So it's just about performing and running some new commands to really load the plugins you want to have. So we will go through this one by one, installing all the things that you might need. And yeah, and here is going a little bit in detail in what this thing is changing. So indeed, running some UV add, and then you add your package, you are modifying some setting file of your repo that is adding as a dependency these plugins that you asked. Yeah, so this is going, let's say, in the detail, but you don't need to know much about that if you don't want, and if you want, you can just read the documentation of the repo, and you will learn all the details. So what you need is just to run few commands, the ones I already showed you, and then yeah, start running it on your VS Code. Yeah, and these are the two commands that you will need to run every day to start the application. So you will start with this command, the API or the backend, the API server, and with this other command, you will start the GUI. Okay, so as you see in this development environment, the API, the backend and the front end are started with two different commands. Yes. So this is a detail that is more telling that these commands that you run are actually written into the TOML file, that is this setting file into the repo. So you can even create your own command here if you need, just looking at this TOML file. So this depends on your interest in taking a look in more detail at this stuff, but you don't need to know about that. Okay, yeah, and this is what you will do also when really starting to develop, also when you start it again tomorrow or in 2 days or next week. So these are the only commands needed, and then you are able to ready to see what you just coded and to test it. Okay, nice. I think I finished for now, so I hope it was not too long, and yeah, thanks.